Hi again. What you are seeing on the screen right now is the graph of the sine being drawn. So this is the function y equals sine x, and you can see that as the x value decreases to -1 and then increases back to negative or to +1, that our y value increases to 1 and then decreases to -1 and then increases to 1 and decreases to -1. So remember, our x value is the size of the angle and the y value is the value of the trig function at that angle. So this is why when you look at the x-axis, you can see that it is in terms of pi, so it's measured in radians. And when you look at the y-axis, it's just measured in units of distance, so 0, 1, 2, etc. Also note that the graph is never greater than 1, and the graph is never less than -1. But because it is a periodic function, it does go on forever in both directions, both in the positive x direction and the negative x direction. So that is a look at the sine graph. I'm going to go ahead and click over to the cosine graph. All right, so now you can see the cosine graph. It decreases to -1, crosses back in the center, increases to +1, decreases again to -1, increases again back to +1. So same idea, that it has maxes and mins. The max is 1 and the min is -1. And then also, as we come back around, our x values are increasing and then the x values are decreasing. The angles, the x value is always increasing. But our y value is corresponding to that by increasing and decreasing. So it's the same shape, it's just shifted a little. So the cosine graph and the sine graph look very similar. They just sort of start, quote unquote, in different locations. I'll give you a glimpse of the tangent graph, but we're not going to spend a lot of time on it. It's a little bit weird, and in this section, we won't spend time on it, but we'll do it later. So here's what it looks like. The tangent graph has asymptotes, because remember, there are locations where the tangent doesn't exist because you're trying to divide by 0. So it repeats, but at -1, at 0, the tangent is when your radians are equal to 0, pi over 2 and 3 pi over 2, you end up with asymptotes. All right, so that was just a glimpse. Back to the sine graph. So here it is again one last time. What you're going to do in this video is you're actually going to turn to your packet and you're going to work on page 3, but we'll do a couple of them together just so you can see. What I'm trying to get you to do is just explore the sine and the cosine functions so that we can start to draw them on our own. So go ahead and turn to page 3. And first things, let's look at our sine function. So this is y equals the sine of theta, or the sine of x. And the first question is, find the y-intercept of the graph. Well, a y-intercept is here, so that's at 0. Y-intercept is at 0. Secondly, you can see that along the x-axis, we're counting in radians, and we're counting by halves of pi. So they want you to find the values of theta on the graph for which the sine of theta equals 0. So remember that theta is your input, that's your x value, and we're saying that 0 is the y value. So if 0 is the y value, that means we are on the x-axis. So find all of the locations where the sine of theta crosses the y-axis. you should have identified 0, pi, 2 pi, 3 pi, 4 pi. What do you think the next one is? 5 pi. So this repeats every pi. It crosses the x-axis every pi. Then they ask you, find the places where the sine equals -1. So -1 is going to be down here and down here. So we have two locations in this image where the sine of theta equals -1. Remember, this graph goes on forever, so there's actually infinite answers to that, but they're just asking on this domain from 0 to 4 pi. So you would just list 3 pi over 2 and also 7 pi over 2. All right, I'm going to leave the rest of it for you to answer. This will be part of your exploration of the graphs. So you're going to go ahead and finish page 3.